Hard to believe, but this was common practice when cleaning condenser tubes up to about 40 years ago. But why clean condenser and heat exchanger tubes at all? Because most power stations require vast quantities of water for the condensing process. This cooling water is taken either from a river or from the sea in an open cycle, or it circulates in closed cycle with cooling tower operation. In the process, particles in the water contaminate the inner surface of the tubes. River water, for example, typically fouls the tubes with layers of mud. Seawater causes bioslime and sediment, while cooling tower systems attract deposits of calcium carbonate. All these fouling deposits have operating consequences. In the condenser of a 1300 megawatt power station, a 0.12 millimeter thick layer of calcium carbonate reduces output by 1.6%. Bioslime, only 0.026 millimeter thick, will cause a similar output loss in a titanium tube condenser of a power station cooled with seawater. Though almost invisible to the human eye, these unwanted deposits still trigger substantial power losses. Other than fouling, cooling water can cause corrosion, depending on the type of condenser tube material. This leads to increased operating cost by raising fuel consumption with higher pollutant emission and the risk of unscheduled outages from corroded condenser tubes. So, logically, since the quality of the cooling water, as the source of fouling, cannot be changed, the condenser must be cleaned regularly. Either manually, and that means reduction of power station output while opening the condensers, laborious, expensive work that also has to be repeated at regular intervals. Or, much easier, with the TAPROGGE system. A model showing how it works. Sponge rubber balls are injected into the cooling water system at the condenser inlet. The differential pressure across the condenser between inlet and outlet is sufficient to press the balls into the condenser tubes and transport them through the tubes, removing the deposits from the inner surface. At the condenser outlet, the sponge rubber balls are removed from the cooling water system by the strainer screens. And returned to the condenser inlet by the recirculation unit. A closed cleaning circuit. The TAPROGGE system cleans the condenser continuously online during actual operation. A simple and effective solution. Simple though it seems, this condenser tube cleaning system was a highly complex development. Its reliability and efficiency in operation is a product of intensive TAPROGGE research combined with experience feedback from customers. The major component of the TAPROGGE system is the cleaning ball. This is the essential tool. To do their cleaning job and keep power stations operating efficiently, the sponge rubber balls must meet specific basic parameters. The balls must be oversized compared to the tube internal diameter. The balls must be thoroughly distributed at the cooling water inlet to ensure they reach all parts of the condenser tube nest. The ball diameter and hardness must be matched exactly to the individual condenser tubes. Depending on application, the balls must accommodate different types of surface coating to help them dislodge stubborn, slimy deposits, for example. To ensure they're equipped with these attributes, cleaning ball production is rigorously monitored throughout the manufacturing process developed at TAPROGGE. Tight, ongoing quality control guarantees that the cleaning balls meet all requirements. They come in many different types to counteract the countless forms of fouling. All in all, in fact, the TAPROGGE portfolio of sponge rubber balls runs to 8,000 different types. The water forces the balls through the tube. As a result, the speed in the boundary layer in front of the ball rises sharply, generating a jet effect that dislodges sand or slime deposits from the tube wall and flushes them out of the tube. The ball removes soft deposits in a single passage. Harder sediment needs an additional scraping, a job for coated cleaning balls. To remove scaling and restore the heat exchanger to its original efficiency, coated balls may need to be circulated several thousand times. But this takes only a few days. Subsequently, cleaning is continued with uncoated balls to stabilize the heat exchanger at its rated level. After cleaning the condenser tubes, the balls are removed from the cooling water system by the strainer screens. The screens are custom designed by computer, taking into account more than 30 different parameters, like cooling water quality, water volume, or flow rate and pattern. An expert system incorporating the experience of more than 5,000 applications ensures that a screen of the right type, inclination, gap width and material is designed and delivered for each project. Here, strainer type D2 with 2 screens inclined like a roof. The apex of the screens points into the cooling water flow. Extensive tests were conducted at TAPROGGE to optimize the transport of the balls off the screen surface. It was found, for example, that the balls tended to run along the straight bars of the screens and then stick at the bar ends between the screen and the tube wall. Only by means of a flow dynamic development program was it possible to work out criteria for the special design of a hydrofoil section which engenders the necessary effects. The hydrofoil section generates a vortex flow which prevents the balls from jamming against the side wall and pushes debris that might block them away from the ball stream. The design and positioning of this hydrofoil component decisively influenced the functioning of the strainer screen. The screens, consisting of steel bars networked with spacers into a screen mesh, are highly robust. At the end of the screens, there are 2 ball outlets. A minimal quantity of water is required to transport the cleaning balls from the screen outlet nozzles back to the recirculating unit. This unit consists of a ball recirculating pump and a ball collector. The ball recirculating pump in monoblock design was developed by TAPROGGE together with a leading pump manufacturer to ensure especially careful transportation of the cleaning balls. The ball collector is situated between ball extraction and ball injection, a porthole to view the balls in circulation. The ball collector is equipped with an integral non-return valve to prevent the balls escaping due to reverse flow. Depending on the degree of automation, the ball recirculating unit can be equipped with special monitoring devices. The BRM monitors the number of balls, while the BOM measures the degree of wear and thus actual ball size. Given the conditions, the ball life can last up to 6 weeks. Balls, downsized through wear to the diameter of the tubes, lose all their cleaning capability. The TAPROGGE condenser tube cleaning system can be operated and monitored from the control room. The programmable control system allows fully automatic operation and self-monitoring of the TAPROGGE system. Alternatively, all system functions can be controlled manually. Over the past 40 years, TAPROGGE has become synonymous with state-of-the-art condenser tube cleaning technology. An idea turned into useful application. Worldwide, more than 10,000 TAPROGGE systems are doing useful and efficient cleaning work on the largest turbine condenser down to the smallest heat recycling heat exchanger of a swimming pool. Among its many attributes, the TAPROGGE system saves fuel and thereby lowers pollutant emission. It's environment friendly, a highly significant advantage for the future. TAPROGGE can help you. As a long-serving partner in the power station industry, TAPROGGE offers continuity and lasting support with all the expertise of a specialist company. System engineering combined with all the experience gained from ongoing system optimization adds up to a unique package, and only from TAPROGGE, your partner.